everyone, welcome to my channel Size App. So today we will be talking about another part of AWS. And before I begin, I would request that you like, subscribe, and comment on my videos because it really motivates me and makes me want to create more content. So today's topic of discussion is application integration. So if you go to docs.aws.amazon.com, you will see under application integration, there are several resources listed. So the ones that I think are most important for both the certification purposes and for general architectures are EventBridge, SNS, SQS, step functions, and SWF. So let's go over what is EventBridge. An EventBridge is a serverless event bus service that makes it easy to connect your applications with data from a variety of sources. EventBridge delivers a stream of real-time data from your own application, software as a service applications, and AWS services, and routes that data to targets such as Lambda functions. You can set up routing rules to determine where to send your data to build application architectures and that react in real time to all of your data sources. EventBridge allows you to build event-driven architectures which are loosely coupled and distributed. Now, those who are familiar with this kind of terminology, you might question what's the difference between an EventBridge and Kafka. So that's something I will cover in another video to discuss the key differences and how both of these work. So for today's purposes, let's just try to understand what is EventBridge, so then later we can compare the two. So EventBridge used to be known as CloudWatch Events, but now it's known as EventBridge. You can configure AWS resources with EventBridge, of course. There's Lambda functions, EC2 instances, streams in Kinesis data streams. Kinesis is part of the analytics resource, and I will discuss that under the analytics video. Log groups and CloudWatch logs, ECS tasks, container service tasks. Manager run commands, some manager automation, batch jobs, step functions, state machines, pipeline in code pipeline, code build projects, SNS topics, SQS topics, both of which I will be covering in this video, inspector assessments. So the concepts that you should really be very familiar with to understand EventBridge are the following. There are these things called events. An event indicates a change in the environment. This can be an AWS environment, a SaaS partner service, or application. So one of your own custom applications or services. So for example, Amazon EC2 generates an event when the state of EC2 instance changes from pending to running. And the EC2 autoscaling generates events when it launches or terminates instances. Then CloudTrail publishes events when you make API calls. You can also set up scheduled events that are generated on a periodic basis. Then the next concept to understand are rules. A rule matches incoming events and routes them to targets for processing. So a single rule can route to multiple targets, all of which are processed in parallel. So you don't have to, it's asynchronous. Rules aren't processed in a particular order. This enables different parts of an organization to look for and process the events that are of interest to them. So a rule can customize a JSON sent to the target by passing only certain parts or by overwriting it with a constant. Third concept to understand are targets. A target processes events. So targets can include EC2 instances, Lambda functions, Kinesis streams, EC2 tasks, and the list that I gave you, which can always subscribe to your topics. Then you have event buses. An event bus receives the events. So when you create a rule, you associate it with a specific event bus, and the rule is matched only to events received by that bus. So your account has one default event bus, which receives events from AWS services. You can create custom event buses to receive events from your custom applications. You can also create partner events. So the way I like to think about this is that you have event buses. So think of if you go to a bus stop, there are buses leaving for Montreal, for Toronto, for New York, and all the passengers are events. So rules define which route it will take and which bus it should take, and the events at the passengers, so where they will be going and which bus. So if your destination is Toronto, then you'll be going to the bus going to Toronto. And if it's New York, then you subscribe to the event bus going to New York. And that's how these the same concept is applied here. The same metaphor is applied here and in cloud terminology. Then you have partner event sources. A partner event source is used by an AWS partner to send events to an AWS customer account. To receive these accounts, a customer must associate an event bus with the partner event source. So that's what Event Bridge is. Now let's move to the next one, which would be SNS. Now, what is Simple Notification Service? Amazon's Simple Notification Service is a web service that coordinates and manages the delivery or sending of messages to subscribing endpoints or clients. In SNS, there are two types of clients. There's a publisher and then there's a subscriber, also referred to as producers and consumers. Publishers communicate asynchronously with subscribers by producing and sending a message to a topic. So they create a topic, which is a logical access point and communication channel. Subscribers, such as web servers, email addresses, SQS queues, Lambda functions, consume and receive the message or notification over one of the supported protocols, such as HTTP or HTTPS, email, SMS, Lambda, or SQS, when they're subscribed to the topic. So a publisher launches a topic, subscribers subscribe to the topic. So when using SNS, you create a topic and control access to it by defining policies that determine which publishers and subscribers can communicate with the topic. So a publisher sends messages to topics that have created or to topics that have permission to publish to. So instead of using a specific destination address in each message, a publisher sends a message to the topic. SNS matches the topic to the list of subscribers who have subscribed to the topic and delivers the message to each of those subscribers. Each topic has a unique name that identifies the SNS endpoint for publishers to post messages and subscribers to register for notifications. And subscribers receive all messages published to the topic to which they subscribe, and all subscribers are essentially receiving the same message if they are subscribed to the same topic. That's all you need to know for SNS. It's simply a web server that coordinates and manages the delivery or sending of messages, as the name suggests, to a pub-sub architecture. Now let's talk about SQS, Simple Queue Service. Simple Queue Service offers a secure, durable, highly available hosted queue that lets you integrate and decouple distributed software systems and components. SQS offers common constructs such as dead letter queues, which is any messages that cannot be processed or any consumers who weren't able to consume the messages. It queues up and holds it in a separate, so to speak, box so that you can go and audit to see why these functions were not working. And it also allows for cost allocation tags. It provides a generic web service API that can be accessed by programming language with the SDK supports. So what are some of the benefits of SQS? Security, durability, availability, scalability, reliability, and customization. So these would become your most favorite words when designing any AWS or cloud infrastructure. Security, durability, fault tolerance, availability, reliability, and scalability. So for security, for SQS, you control who can send messages to and receive messages from an SQS queue. There's server-side encryption that lets you transmit sensitive data by protecting the contents of messages in queues using keys managed in KMS, which is Key Management Service. In terms of durability, it ensures the safety of your messages. SQS stores them on multiple servers. Standard queues support at least one message delivery, and FIFO queues support exactly once message processing. So like FIFO queues is first in, first out. So those are some terminologies I will deep dive into my later videos. In terms of availability, SQS uses redundant infrastructure to provide highly concurrent access to messages and high availability for producing and consuming messages. Scalability, SQS can process buffered requests independently, scaling transparently to handle any load increases or spikes without provisioning instructions. Reliability, it locks your messages during processing, and multiple producers can send and multiple consumers can receive messages at the same time. And you are able to customize it too, so your queues don't have to be exactly the same. For example, you can set up a default delay on a queue, or you can store the contents of messages larger than 250 kilobytes using S3 or DynamoDB with Amazon SQS holding a pointer to the S3 object. Now, how is it different from SNS? So SQS and SNS are queue and topic services that are highly scalable, simple to use, and don't require you to set up any message brokers. So for simple notification service, it's a notification service, as the name suggests, and queuing is for queuing purposes. Now, there's other concepts that you should be familiar with, even if you are to pass the associate exam or the professional exam, but I will have to dedicate another video to that. So for the sake of this video, let's move to a high-level understanding of what SWF is. SWF is Simple Workflow Service. A simple workflow service makes it easy to build applications that coordinate work across distributed components. So a task represents a logical unit of work that is performed by a component of your application. So coordinating tasks across the application involves managing inter-task dependencies, scheduling, and concurrency in accordance with the logical flow of the application. SWF gives you full control over implementing tasks and coordinating them without worrying about underlying complexities, such as tracking their progress and maintaining state. So when you use SWF, you implement workers to perform tasks. So these workers can run either on cloud or EC2 or your own premise. You can create tasks that are long-running, that will fail, that will time out, require restarts, or that may compete with varying throughput and latency. So SWF stores tasks and assigns them to workers when they're ready, tracks their progress, and maintains their state, including details on their completions. To coordinate tasks, you write a program that gets the latest state of each task from SWF and uses it to initiate subsequent tasks. So SWF maintains an application's execution state durably so that the application is resilient to failures in individual components. So now think of the SWS service as like how bees function. There's a queen bee, which is SWS, and it holds on to all the tasks, and when the time is right, it delegates to its workers. And that's essentially, metaphorically, how I visualize SWF to work. Simple workflow. Now, step function. Step function makes it easy to coordinate the components of your distributed applications as a series of steps in a visual workflow. And it just visualizes your workflow for you. So at a high level, this is what the application integration components are. I hope you enjoy my videos, and I hope you will subscribe to my channel, and maybe leave a comment if you like my videos so that I can continue making more. So until next time, bye.